All right, so let's go ahead and take a look at using quadratic formula with real world models. So using the quadratic formula to solve real world problems, okay? Let me scroll up a little bit to get more room. Let us remember what the quadratic formula looks like. It is x equals negative b plus or minus radical b squared minus 4ac divided by 2a. So let's take a look here. It says a diver jumps from a platform 10 meters above the surface of the water. The diver's height is given by the equation h equals negative 4.9 t squared plus 3.5 t plus 10, where t is the time in seconds after the diver jumps. For what time t is the diver's height 1 meter? So we need to take this equation here and rewrite it, except we want to make h equal to 1, and I'm going to put it on the other side. So that is going to look like this. Negative 4.9 t squared plus 3.5 t plus 10 equals 1. And remember, we want our equations to be set equal to 0. So I need to subtract 1 from both sides. And this gives me negative 4.9 t squared plus 3.5 t plus 9 equals 0. So now that my equation is equal to 0, I can use the quadratic formula to plug in a, b, and c and find my solutions. So remember, we want to use parentheses so that we can substitute correctly. So x equals negative, here's b, plus or minus radical b squared minus 4 times a times c, and all of that over 2a. And let's plug our numbers in. So my b value is 3.5, so that goes here and here. My a value is negative 4.9, so that goes here and here. And my c value is 9. Okay, so now we're just going to go ahead and work this out. So we have here negative, I'm going to come back up to the top here. So we have here negative 3.5 plus radical, and 3.5 squared is 12.25. And then negative 4 times negative 4.9 times 9 is 176.4 positive. Over 2 times negative 4.9 is negative 9.8. Okay, we can go ahead and add 12.25 plus 176.4, and we get 188.65. So now we have negative 3.5 plus or minus radical, or the square root of 188.65 divided by negative 9.8. And we can go ahead and get the square root of 188.65, which is an irrational number, so we're going to round it to the nearest hundredth. So we have negative 3.5 plus or minus, and the square root of 188.65 rounded to the nearest hundredth is 13.74, and that is over negative 9.8. Now, if you remember, from here we're going to make our two different fractions. So one fraction is going to be negative 3.5 plus 13.74 over negative 9.8. And the other fraction is going to be negative 3.5 minus 13.74 divided by negative 9.8. So let's go ahead and work these out. So negative 3.5 plus 13.74 is 10.24. over negative 9.8, and 10.24 divided by negative 9.8, rounded to the nearest hundredth, is going to be negative 1.04. Let's solve the other fraction. Let's simplify the other fraction, better said. So negative 3.5 minus 13.74 is negative 17.24. Divided by negative 9.8 and rounded to the nearest hundredth is approximately 1.76. Now, remember, when we're dealing with a real world situation, like here we're measuring the amount of time it takes for the diver to reach a height of 1 meter, well, we're counting time in seconds, and we cannot measure time in negative seconds. So the answer of negative 1.04 seconds, that doesn't make sense. So the answer that makes sense is 1.76. So it takes the diver about 1.76 seconds to reach a height of 1 meter. All right, next example. It says here, the height in meters of a model rocket on a particular launch can be modeled by the equation h equals negative 4.9 t squared plus 102t plus 100, where t is the time in seconds after the engine burns out 100 meters above the ground. When will the rocket reach a height of 600 meters? So again, we're going to write this equation, except h is not going to be on the left. We're going to put h on the right, and h is going to be equal to 600. So that's going to look like this: negative 4.9 t squared plus 102t plus 100 equals 600. And we need to set this equal to 0, so we have to subtract 600 from both sides. We get negative 4.9 t squared plus 102 minus 500 equals 0. And now that we are set to 0, we can go ahead and plug this into our quadratic formula. So negative b plus or minus, I should put x equals here, right? Negative b plus or minus radical b squared minus 4 times a times c over 2a. Again, excuse my wobbly lines, and let's plug in our numbers. My b value is 102, so that goes here and here. My a value is negative 4.9, that goes here and here, and my c value is negative 500. All right, so we have room down here. We're going to keep working this out down here. So we have here negative 102 plus or minus. Here's our radical. Let's go ahead and work this out. What is 102 squared? It is 10,404. And then here we have negative 4 times negative 4.9 times negative 500. And that equals negative 9,800. And we know from the previous example that 2 times negative 4.9 is negative 9.8. Okay, so I'm going to finish this up here on the right hand side. And we have negative 102 plus or minus. And here we have 10,404 minus 9,800 is 604. That is over negative 9.8. And we can find the square root once again of 604. And 604, the square root of 604 would be an irrational number, so we're going to round it to the nearest hundredth. So we have negative 102 plus or minus, and the square root of 604 rounded to the nearest hundredth is 24.58. And all of that divided by negative 9.8. So now we have our two fractions. Let's write down our two fractions here. Our first one is going to be negative 102 plus 24.58 divided by negative 9.8. And our second fraction will be negative 102 minus 24.58 divided by negative 9.8. So, first fraction, negative 102 plus 24.58 is negative 77.42. And negative 77.42 divided by negative 9.8 is approximately positive 7.9. Second fraction, negative 102 minus 24.58 is negative 126.58. Divided by negative 9.8 is approximately 12.92. So you see here in this situation, both of our solutions are positive. So this looks here like the rocket reaches a height of 600 meters twice. And that is actually true, because this is a model rocket. So what's going to happen here is the model rocket is going to launch up into the air. After 100 meters, the engine's going to cut off, but its momentum is going to keep taking it up, and it's going to reach a height of 600 meters at about 7.9 seconds. You see that right here. Then it's going to keep going up, and eventually gravity's going to take over, and that model rocket is going to start falling back down to the ground. And as it falls back down, it's going to pass that 600 meter mark again on its way down, and that will be at 12.916 seconds, which we rounded to 12.92. So, as far as solving this problem or answering this question, I believe that 7.9 is the better answer, because I think that when you're talking about when will the rocket reach a height of 600 meters, we're kind of, I would guess that what you're focused on is on its flight path upward, on its upward motion, not when it hits 600 meters falling back down. So that's why I would say the answer is 7.9 seconds. All right, a soccer player uses her head to hit a ball up in the air from a height of 2 meters with an initial vertical velocity of 5 meters per second. The height h in meters of the ball is given by h equals negative 4.9 t squared plus 5t plus 2, where t is the time elapsed in seconds. How long will it take the ball to hit the ground if no other players touch it? So the ground is 0, right? So we're going to write this as negative 4.9 t squared plus 5t plus 2 equals 0. So since this equation is already set to 0, we can go ahead and plug this into our quadratic formula. So x equals negative b plus or minus radical b squared minus 4 times a times c, all of that over 2a. And let's go ahead and plug our numbers in. So our b value is 5. That goes here and here. Our our a value is negative 4.9. And our c value is 2. So I'm going to work this out. So we have negative 5 plus or minus, here's our radical, 5 squared is 25, and negative 4 times negative 4.9 times 2 is 39, positive 39.2. And we already know what negative 2 times negative 4.9 is. That's negative 9.8. And now we can add together 25 and 39.2, and that gives us 64.2. So we have negative 5, let me use a different color, negative 5 plus or minus the square root of 64.2 divided by negative 9.8. And so when we get the square root of 64.2, and we round it to the nearest hundredth, we get 8.01. So let's come up here, and we have here now negative 5 plus or minus 8.01 divided by negative 9.8. And now we have our two fractions. We have negative 5 plus 8.01 divided by negative 9.8. And we have negative 5 minus 8.01 divided by negative 9.8. And we work these out. Negative 5 plus 8.01 is 3.01. And 3.01 divided by negative 9.8 is approximately negative 0.31. And let's do the second fraction. So negative 5 minus 8.01 is negative 13.01. And negative 13.01 divided by negative 9.8 is approximately, when we round, 1.33. So we have a negative answer and a positive answer, and so we think about measuring how long it takes the ball to hit the ground, and we can only measure that in positive time. So therefore, the solution is that it will take the ball approximately 1.33 seconds to hit the ground.